My name is Ben Curry, and thank you so much for having me here, Steve, and all the great guys at CK. And this is a brand that's near and dear to my heart. If you don't know, I worked years, literally now, I guess, at working on the SharePoint Best Practices brand. And they're really, where's Spence? Is he around still? Overused, misunderstood, and I hate to say this, but I feel like at times they're now just being exploited for personal gain or politics or budget or something else. So as we go through this farm performance discussion, I'm going to be talking about the best practices, oftentimes a compromise. So as we talk about things like your server architecture or your capacity planning or how much memory do I need, the best practice is usually your best practice and nobody else's. It's totally unique to your situation. Rarely does a best practice, especially when it comes to performance, apply to everybody. It's part expert advice. There's nothing wrong with that. You guys are at, I think, the best conference in Europe right now. There's a lot to be said for getting experts' guidance from those who have been there and done that. TechNet, MSDN, your local user groups. I know him in the back from Paris. But also your technology. But you'll see I've intentionally put the technology as the third. I think expert advice and business strategy. Like people come to me and they say, we do a lot of performance engagements, and they say, I need a fast farm. And the first question I ask is, what does that mean? What's fast? 6-second page time, 3-second page time? Oh no, it has to be immediate. We're doing one now for a healthcare company. We're storing about 10 million items in SharePoint, and they need those to be instantaneous to the doctors that are accessing the system. And these are huge, like 2 and 3 megabyte files. That's where you've got to work with them to help them understand there isn't necessarily instantaneous. We ended up doing a Silverlight previewer to fix this problem. But then, what is maybe that's just for Europe. What about for your Australia, APAC connections? What about for your Africa connections? Oh, maybe that's a 7 or 8 millisecond page load time, and that's acceptable there. So it's a moving target. So know exactly what your levels are before you start testing for performance. Obviously, we know a 60-second page load time, well, is that good or bad? Well, that's probably bad in most people's environments. This is who I am. Besides being out of breath, I apologize. I actually ran here from the Crown Plaza. I do SharePoint. I do lots of it. Prior to being an owner at Summit 7, I was one of the owners at MindSharp. And before there, I spent about a decade in the NASA data center. So I was one of their 4 global architects. And so I spent years in a room that's 66 degrees Fahrenheit. I don't know what that is in Celsius. Cool. And low humidity. So to this day, I still have an affinity for a nice, cool room with a hard raised floor with low humidity, because I still feel like I'm home. I had 2,200 servers there, and I still miss my racks and racks of servers. They were like children, you know, and I knew exactly where my machines were, and I could go touch them, and they all had nice, pretty names. I am Curry Ben, and I probably still know most of them. Hey, you know what I mean? Anybody work like global, like big business, and you have these really odd server names, yet you never forget them? And you hire some consultant in, and they're like, how do you remember all of the names and every IP address? So I lived it for years and years. You can't fix stupid. That's the #1 thing we talk about in farm performance. This actually was a great story. Come off stupidcarowners.com. Somebody went out and bought a brand new Ferrari. Guys, this is like a half mile from the dealership. No amount of money is going to fix your performance problems long term. You can throw some hardware at the problem today, and you can try to make it better. But as we go through the session today, remember, nothing replaces engineering. Proper systems engineering is key. Using a test tool, not guessing. Gathering requirements. Defining your performance targets. All of these basics that a lot of you, how many people in here did Windows 351, NT 351? So all of you have been there, right? We know. We used to have to do some guessing. 1994, we guessed a little sometimes. But we shouldn't have to guess today. Sometimes accidents happen. There's nothing we can do about it. From our best planning and all of our servers and all of our Visual Studio testing and Load Runner and routers and F5s and Sometimes we still miss something, and it's okay. I'm just here to comfort you and pat you on the back, and when it happens, you'll say, well, he told me I get a mulligan. Everybody gets a mulligan when you're building out a large server farm. It happens. And guys, even if you were to hire me or Steve or Paul or somebody in, we make mistakes too. It's a beaver in case you don't see it. Even experts make mistakes, okay? Now, we shouldn't be that far off. I might say, well, I'm not handling 200 or 2,000 concurrent users. I'm only getting 1,300. But I shouldn't be in a place to where the target was 2,000 concurrent and I'm getting 5, right? So, but we can get pretty close. This is what we're going to talk about. Some about the farm architecture. Spence and Steve, and there's tons of other people here discussing farm architecture in depth. I'm only discussing farm architecture from a performance and kind of a bit high-level performance overview. I'm going to introduce you to some testing tools. Steve Smith, when is your session, Mr. Smith? Wednesday afternoon. Steve Smith will be showing you the tools to do exactly what I'm talking about here. So if you want to see what I'm talking about put in practice, go find Steve. I'm going to end with some of the logging and monitoring and just some of the things you want to be looking at in the performance counters. If SharePoint 2007 was a Swiss Army knife, I mean, we heard that a lot, didn't we? You know, we took 2003 where our primary objective with SharePoint was looking at content. As much as we wish 2003 was more, it was a glorified file share with some tasks and calendaring. A few of us had workflow running, but it was really just content in place. In 2007, what we really saw was this change towards shared services, these utility providers, and that added a new dynamic to capacity planning and performance. Things like user profiles and the robust search and the BDC and Excel services and all of these things that we thought were terribly complex and we would never sort out, yet we did. And most of us today look back at 2007 and they say, well, this isn't too hard to architect. This was actually quite simple now that we're looking at 2010. All of these service applications out of the box, BCS, Excel services, Performance Point, Power Pivot, Search, InfoPath, State Service, Secure Store, Visio services, Access services, Document Conversion services. Do you really want to install all of this at once and hope for the best? Well, the answer is no. Oh, by the way, I love SharePoint 20 ECM. I was a little, by the way, just because I like the picture more than anything. I was like, no, that's cool. This is some of what I'm talking about. This is intentionally PowerPoint overload. These are just, this is not all of them. It's a lot of it. And what a lot of people aren't taking into account in capacity planning is the client. What we're seeing now in real world is that the concurrency rates are going up over 2007. Things like SharePoint Workspace, Caligo client. We're seeing the proliferation of the offline clients, and that's actually increasing the concurrence. But what I'm finding is very much increasing the usability of the system. So things like offline clients get people to use SharePoint, but then you have to plan for it as well. House of cards. Is that familiar? That's a global term, isn't it? Yeah? You build this, and this guy's about to thump this card on the bottom. You can have all of this beautiful architecture and all of your service applications and have your devs write some really slick code. And I'll see something like a 32-bit SQL server here on the very bottom of this stack. And what happens when it topples? Everything goes. If something seems complex, this is my golden rule, it probably is. I'm not here to scare you away from 2010. I'm just saying we're going to have to respect the architecture of it. You don't get to not do the logical architecture or not do the SQL architecture. You actually get to do all of it. How many people love gathering requirements in here? Yeah, that's what I thought. It's usually like 1, 2. The requirements are critical to getting a well-performing farm. I can't stress enough. The first thing you need to do is create your logical architecture. Your web applications, your service applitions. Understand what the farm is going to do. Or farms, maybe multiple farms. If you start trying to build out your physical architecture before you've spec'd the logical architecture, you're guessing at best. We start at the fringe, out with the documents, out with the services, and we architect our way into the middle or down to the farm level. Talk to the business first. How are they using the system? Is this an InfoPath Forms? Is this a public website with publishing? Are we heavily using Excel services? Are we dropping a lot of access services into here, into the farm? Is it mostly just collaboration? We have to first understand what we're doing with the system. How many consultants? Anybody consultants? Yeah. How many times you sat down with a client? I hear this every other time. How many servers do I need on day one? Well, you need N. The answer is N, by the way, for those of you who are math majors. It's just N. I don't know yet. And they'll say, but you're the expert. How can you not tell me how many servers I need? I'm like, well, I can if you know some things. How many users use Excel services in a given 60-second period? What size are those spreadsheets? How complex are the formulas? Oh, I don't know, I don't know, I don't know. And I try to help them understand that is why we're doing discovery. That's why we're getting requirements to build the farm. You've got to be really careful with that. You can actually come across as a little arrogant and get in trouble. But I think just helping them understand there's a lot of things you have to know first. From there, you can go build your physical architecture. Right? From there, I could say, I need to crawl 15 million items. For one, you may be looking at fast at 15 million items, but we already know you need at least 2 crawl databases. You have 10 million rows in a crawl database. We know over 10 you need 2. So at a minimum, we're up to, see how that's starting to define our physical architecture. The same with managed metadata services. Let's say that I needed one for my content management system and I needed one for collaboration. Well, I may now have 2 managed metadata services with 2 databases. So that starts to define, all of those services and web apps define our physical architecture. Nothing's more important than testing and validating your results. I use Visual Studio Ultimate because honestly it's free to me as a gold partner. I like it. I've used LoadRunner. There are lots of tools available. I think the most important thing here is don't guess. Know. Have a really good idea before you put users on what your load will be. And last, it's going to change. So constantly log and monitor. I am thirsty now. Wow. We have to get out of the idea of 2007 that we have this fixed tiered architecture. I have 2 web front ends. I have 3 app servers. These servers run Excel. This server runs search. 2010 doesn't work that way. There's so many services in the farm. We need to estimate the number of servers in the farm. And then we need to continually refine that load. We're actually down in new farm deployments as short as every 14 days in the beginning, looking at the farm, the metrics on the farm, what was Excel using, what was access, what was search, and adjusting and redistributing those services on the servers. What you'll find over time is you'll have to tweak that less and less. But a lot of these are new services. So you don't know exactly. You can do all the business requirements in the world, but you don't know really how these people are going to use it, how high the adoption rate will be. So don't try to have a fixed farm topology. Have it something that you constantly log and monitor and you adjust your architecture as needed. Don't be afraid to adjust the architecture. My wife said this looked like a snail, so now I have to redo it. When you're architecting for availability, oftentimes we have a couple different containers. One is the logical container that we think about a site lives in a site collection, lives in a content database, lives in SQL Server. So to make a site highly available, we have to make SQL Server highly available. Well, for SQL Server to be highly available, what else has to be highly available? It's the number one thing we think of, storage. So our disk, whether it's SAN or whether it's DAS, hopefully never NAS for databases, but SAN or DAS. But we also have to think about how are these sites rendered? Well, these sites are now rendered through IIS, so that's my web service. Those have to be highly available. Internal at Summit 7, we talk about a couple different types of load balancing or distribution. I talk about network load balancing or hardware load balancing, and that's something done outside of SharePoint, done by F5s or Foundries or Windows NLB. When we talk about service distribution, it's something we more talk about internal farm architecture, and that kind of helps us understand with each other. I think consistency is what's important when you're doing designs. And don't forget the external systems and all the services. I'm seeing external systems as a huge pain point in performance in 2010 in real world because we're using more and more PeopleSoft, SAP backends, JD Edwards, Lawson. Insert your line of business system. We have business critical workflows that are pivoting on data found in some other system. So what is your availability requirement of that system? What's the latency to that connection? BCS is fairly tolerant of latency, but maybe not across the pond, just west of Ireland. I'm going to do this. This is really boring. How many people have seen this slide over and over? I'm going to show you again. This is what TechNet says as of now. It's too low. From what I've seen real world, by the time you put some server antivirus, you put the operating system on it, you turn on the services, 8 gig is almost the server footprint in a lot of ways for a lot of organizations. So what we see is a pretty dramatic increase to go from, say, 8 gig to 12 gig. Right? A lot of people are trying to put in lower systems because they're running VMware or Hyper-V, and so they're trying to get out of here with 4 or 6 gigabytes of RAM, and it's just not enough. I can tell you now from several 2010 farms, 4 to 6 gig is not enough on a box. 12 to 16 is probably a great starting place for most web front ends. But 8 gig, think 100 users or less type of installation. But what you'll find is you can go from 8 to 12 and get a ton more users, maybe another 200 or 300. I mean, you're going to get a big jump by going up to 12. It is 64-bit. The system drive, it is on TechNet. I know everybody's trying to get around this. It is an 80 gigabyte C drive. System drive is 80 gig. It's for logs. It's for loading solutions. Don't try to break this rule. Microsoft wants 80 gig for support, and that is a hard line in the sand on TechNet as of today. SQL servers, 8 gig is not, it's just not. 16 gig should be the real minimum on your SQL server. First, let's talk a little bit about service application architecture as it is to performance. I know Spencer Harbar has a session here on service application architecture in depth, and one on user profile application as well. I highly recommend those sessions if you're building a farm of any size or complexity. Most service applications have a database. Service applications have an application pool, same as a web application, where it runs on the server and processes. When we talk about performance and availability, multiple servers can run or process data for a service application, such as Excel services, user profiles. Those are InfoPath. I'm going to show a average. If you were to take all of the service applications in 2010 and you were to shake them up and pour it out, you would get the average. And this is kind of the way, and I'm going to show you 3 front ends and 3 app servers just for demonstrative purposes. The only one that's actually architected this way is managed metadata. So to give you an idea, the first thing on a service application is we have a service instance. And that just means you've installed the software. So a full install will actually put the DLL or the binary on the box. That's a service instance. When we turn on that service instance, it becomes a service machine instance. That means you've turned it on. So when you install it and when you turn it on. A service application must have 1 or more service machine instances. This is your basic scaling and performance of service applications. Not every service application scales this way. Most do. One notable is the synchronization service for user profiles. It only runs on 1 box. Most of these have a database, you'll notice. Search has several, 3 or more. User profiles has 3. Managed metadata has 1. So it depends on the service application how many databases you have. Now this performance is completely separate from the application server. What I'm going to do is continue to build this out. The service application proxy connects from the web servers to the service application. It's magic. They do have magic. And this is not a WCF proxy. Okay? The proxy is totally dependent on how the developer wrote the code. This is proxy in the most generic sense. It says, I'm a web application. How does this web application communicate with a service instance? And it does that through a proxy. You'll see this proxy running on the web servers. If you go into service application, I call it manglement, service application management, and let's say that you were doing inter-farm federation, you would actually see only the proxy running on the consumer farm. That's all it needs to connect back to the parent farm. Kind of give you an idea of an overview. Like I said, Spence is going to give you details of the user profile application. This is kind of the breakdown of a unique one. So here we have our databases. We have our synchronization database, our profile database, and our tagging database. So this service application has 3. When you're back here, think, this database looks really small over here in the corner, but we still had to architect SQL to make this highly available and performant. A common problem with service applications and web applications performance is SQL doesn't have enough juice. There's not enough available I/O. It's either being shared with Exchange Server. I see that a lot, right? Well, where does your drives come from? Well, mine's coming from a EMC DMX3, and I know that's fast. And by the time we actually go back and look at it, we see what they've done is taken a RAID array, and they've carved up part of it for Exchange, and part of it for SQL, and part of it for something else. And what we get is nothing performs well. Search is going to be a scaling issue for most people. We used to think 1 million items was a lot of items. 1 million items isn't that many items, is it anymore? If we go crawl a file share, we can get 1 million items at not very big companies now. Because who deletes something on your file shares? Will you delete stuff off your file shares? I'm not deleting it. I've interviewed 1,000 or more business users. I'm like, why don't you clean up your file share? Well, let's say I don't know who owns that, and I might need that one day, or I might get in trouble. Or that's IT's problem. That's with our computer people. They clean up our file shares, but we actually can't. So we get stuck crawling all this data. Well, that takes juice. The index server is gone as we knew it in 2007. So the idea that we have a box that goes out and crawls and builds an index and propagates L1 or indexes to our web query servers or web or query servers, those days are gone. We now have essentially a stateless search service. So those who have never seen SharePoint 2010 before, it's actually quite easy to learn search. Well, I have a crawl server. What does it do? Well, it crawls stuff, and it takes that data and it sends it to the query index server. Well, that makes sense. But us old school SharePoint people, we were used to the index server doing the crawling, and the query, it was just a little off. Now it makes total sense. The crawl server goes out, crawls the data, brings it in, and puts it on the front end servers. Be sure you account for that network traffic on a busy farm between your crawl server and your query index. Query index can't be split up anymore. Query server is an index server. There's a lot to Search 2010. This session is not about Search 2010. Don't forget your databases. The property database is one of those databases in 2010 and 2007 that gets really, 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 really busy. I've seen recommendations on TechNet as high as 2,000 IOPS for that disk. If you go down here to the local computer store, what's a really fast SATA drive? What, like 240 IOPS? So think about that. How big of an array do I have to get search? There's Alderman. I know Brian knows. It's like 8.5, right? Somewhere in there. I'm not perfect at math. But it's going to take either really fast disk or large arrays to get performance for the property database. Why is the property database so busy on a farm? Yeah, it's permissions. It's ACL trimming. Every time a user executes a query, it says, who has access to read this? It goes and looks in the property database to find out what the permissions are for the object to return the search result. And it gets very, very busy. Also, it stores all of the metadata. Permissions are metadata. Stores all of the metadata for the objects as well. One of the things we do to help performance here, let me get to it, is we sometimes put a web front-end crawler target. You'll see that TechNet still talks about the crawler target, but yet there's no crawler target in the UI. In 2007, when you were in central administration, you'd open up search, and it would say, which front end is dedicated for crawling? Remember that? Well, that's gone in 2010. Do you know what that did in 2007? It went and modified the host file. That's exactly right. And if you were SSL, it probably broke your host file in 2007. It didn't always manipulate that correctly. So in 2010, they still had this thing called a web front-end target. It's just manual. So here's what you do. You create a web front-end, you join it to your farm. But it's separate than your two web front ends over here, your load balancing. So your users are coming through these two servers. You create this like 6 gig, 8 gig virtual box that no users ever connect to. And what you do for all your web applications, you just go to your crawl server and put it in the host file. Modify the IP address to go to that box. So anytime I go to portalmycompany.co.uk, oh, look at that. It was good, right? From the US. It's always .com. It's never quite as funny when you have to explain it. That's okay. But the idea is that I'm going to tell the crawler which server to go crawl. So what I'm going to do is during crawl times, I'm not going to impact the web front ends my users are on. I'm going to go use a different web front end I've dedicated for crawling. That's a target for crawling. The great thing is, in large corporations, I can actually use this inter-farm. I can still use that same dedicated crawl server from one server farm to another server farm. It's just a host file trick. So, remember 2007. Let me take you back, a little nostalgia here. We had 2 web servers, an app server, and 2 database servers. Look familiar? A lot of us ran this configuration. We were really very content-centric in 2007. And we did have search and index, but you know, if the index failed, that's okay. I've got a copy on my web servers. One exception to this was often Excel services. I might have 2 application servers for Excel. And this is where most companies started. Oh, and document conversions, because everybody used those. How many people use document conversions? 2. That's about right. Yeah, they spent a lot of money on that to nobody use it. 2010, and this is Lori Goen did this originally. This was a small server farm for a client. And just to give you an idea of the difference in the farm, and this is not even half of the service applications in 2010. This was a basic farm for a few hundred users. And what you're going to see is all of the different services. The services, let me stop a second. As you roll out 2010, I'm willing to bet money, you're going to find your services are as important as the content. You have to protect the services just like you protect the content. People can't get to their Word document, they're upset. But now what we're doing is we have dashboards, we have Power Pivot, we have Performance Point, we have Excel. We're getting business data. Executives are making business decisions based on a dashboard. We do this with manufacturers all the time. If they can't get to that dashboard, trust me, that service was every bit as important as HR not getting to that form. We have to now quit treating services like red-headed stepchildren, right? They're first-class citizens. So when we look at 2010 architecture, back to the slide, your regularly scheduled programming, you're going to see that not all of these for this client, only the ones the SLA required are on both servers. A lot of people try to wrap a single service level agreement, SLA, around the entire farm. Well, you don't have to do that. Usually that's dramatically increasing the cost of your server farm. Perhaps my content is a 4-hour RTO and RPO, but maybe search is 24 hours. And maybe Excel services is 30 minutes. So we can have multi-level SLAs in a single farm. Don't forget the databases. Most people are still clustering. You can do mirroring. After reading Neil Hodgkinson's book, he's writing on the best practices book with us. By the way, I don't know half of what he said in his chapter, so it must be good. But I started to understand how much we're probably still going to be doing clustering today. Mirroring gets you away from single instance storage, and that's actually one of the few benefits that I think we're seeing in real world. Spencer, Neil, the right people to ask. Here's an example of a server farm we just implemented. This is a big company, right? This is 40,000 users, not a global company, but a big enough. The reason you'll see all of these web front ends down here, 7 web front ends. You know what that was for? It's because they're going to come in very shortly and do Office web apps. The performance test on that, if you go get the capacity planning white paper off of TechNet, it is 3 web front ends and 2 application servers for, I think it's 300 or 500, somewhere in there, concurrent users. It is a massive beast of an application. So Office web apps. To give you an idea of this farm distribution, I'll walk you through it. Obviously, I just realized that, there was K2 in it. We did offload the workflow out of the farm. I like lots of different workflow products. I'm not here preaching one. It happens to be the Visio I pulled. But you will see that we have 4 application servers distributed in the load. And you can see we've said don't do a fixed topology. The other thing to notice in large organizations is we scale by 2. We never scale our application tier by 1. Because everything I do is redundant. Because our services, remember, we're going to treat them like they're a first-class citizen here. So every time we add a server, they're going to go from 4 application servers, they would go to 6 at that level if I needed to scale out further. We found in testing, they're initially running SharePoint Search 2010. They're crawling about 13 million items. That's where that number came from. We couldn't do it virtually. We tried. ESX is what they were running, or vSphere 4. We could not get the performance. Too slow. So what we did is did a boot from SAN because their failover still required this 2 data centers. That's okay. We'll continue to run off SAN. And so what you'll see here is we actually ran 2 crawler servers and the query index on one with the search databases. They're dedicated RAID sets on the back end. You'll see over here is where we put our crawler target. And that was just the entry point for crawling these 13 million items to take that load off of the web tier, which was already getting hammered. Company with almost unlimited money. This one wasn't about money. You can see here that future phases, project server, Office web apps, Power Pivot, Sandbox Solutions, Secure Store, Business Connectivity, Access, and Visio. They're putting those off for 12 months because this is a lot to bite off for the first year. Because it can't fail, right? This is a business critical system. So even a company with big deep pockets using some common sense to say, I'm going to do this for 12 months, and then we're going to start adding these services to the business over time. Let's see how this works. Let's get these services sorted on the service, on the application servers, and then we'll move forward. There's the link for TechNet. I read through the entire capacity planning when I prepped for this in October at TechEd. It took me about 80 hours, so it's fun, right? So 1 week. You can do this in a week. If you go to that link and you read every link from that article and every sublink, it's about 80 hours. And I will tell you, I got a new appreciation for the people at TechNet. I mean, people from Microsoft here. I love Microsoft, by the way, and I'm being recorded. I love developers, I love end users, so there I said them all at once. The performance stuff on TechNet is really, really good. I don't know about you. The 2 ways I learn technical architecture, I either take a performance class or I take a security class. Those are kind of the 2 ways that I learn technology. All the others just, I have a hard time getting interested in it. If you spend the 80 hours reading everything off of this link, you will actually have a good understanding of SharePoint 2010 architecture. Not just for capacity and performance. You'll just have a good idea of 2010 architecture. It'll give you a good idea about some best practices and prescriptive best practices. Next, define your targets. Know what you're shooting for. If you don't know what your target is, you've got to get people to say 2-second response time, 3-second response time. Maybe to APAC, it's 8 seconds. Those are average numbers. That's why I keep using those. They're kind of what resonates throughout the industry. What do you guys get for long-haul response times? What's acceptable? 2, yeah. We find, and it depends on where you're at, some people are more tolerant of latency than others. So it really depends on the culture as well. All right. You'll go out to TechNet. So as you're reading through that TechNet link I just gave you, you'll see something really cool like, how many documents can I have in a document library? I'll go look at them. 30 million. Cool, I can do 30 million items. What's the maximum blob size? What's the maximum theoretical upload in a 2 gigabytes? But what's the default upload size? 50 megabytes. See, a lot of these stats are based off the default. So if I said 30 million documents, I can't have 30 million 2 gigabyte documents. Well, those estimates were built on 30 million documents at the 50 megabyte upload size. So what you have is as you lean on one of these software boundaries, you're going to be reducing another. So you can't go stretch it at both ends. It's like you and a buddy and take a rubber band and you pull it and pull it and pull it and pull it and you were 10 years old and see who broke and got hurt, right? That's what you're doing. If you try to take two ends of the capacity and you stretch and stretch and stretch and stretch, it will break in the middle. Same thing with like content databases in a web application. Ooh, by the way, we now get 300 instead of 100, right? Well, great. What's our recommended maximum size? About 200 gigabytes. What I don't want to do is go 2 terabyte databases with 300 content databases on a single web app. That would be suboptimal in any country. Some of the web application boundaries, you will notice the 300 per database. Is that a hard limit? Can I go to 301? Sure. PowerShelled it. It was quite easy. Why is it 300? Let's step back and think for a moment. Users connect to a web application server, and that's through an application pool. How does that server connect to the content database? Well, via the application pool. Okay, so I have one content database for a web application, and it has one content database, so I have one SQL connection. What happens when I add 2 web servers? How many connections do I have? I'll give you a hint. That's 2. So we'll say we have 3 web servers. Well, that's 3. Now I add 2 content databases to that web application. How many SQL connects do I got? Well, I've got 6. I add another content database. See what's going on here? How it goes like this? So what you'll see, imagine having 300 content databases on a web app. You're just going to get a really busy network between your web front end and SQL. Now, I'm not saying you have really big content databases. Actually, really big content databases don't bother me at all. I said it out loud. What bothers me is really big site collections. You get table, 2010 is much, much better at SQL locking, blocking issues we had in 07. Stored procedures are a lot better. Big site collection still, with a heavy user base, you're still going to get some locking. So here's kind of the rule of thumb. I either take a really big site collection with a few number of users, and that'll actually work pretty well. Or I take a small site collection with a ton of users, and that'll work pretty well. But if you take a lot of users on a really big site collection, you're going to get locking, probably. I can't guarantee that, but the odds are, actually I probably almost can. It's going to be suboptimal. Managed path, 20 per web app. It's a supported threshold. You'll see there are some differences here. Some are a hard threshold you can't go over. Some are supportability. You can go beyond 20 managed paths, for example, but your performance will start to suffer over 20. And if you want to know why, it's Spence at hardbar.net. Oh, I'm sorry, it's Ben at s7sys.com. Application pools is 10 per server. Guys, this is a hard limit. We've argued this on the MVP thread, I don't know how many times. It is 10. No matter how much memory you've got in this box, Microsoft is saying 10. And I honestly 100% don't know why. What about content databases? They still recommend 200 gigabyte per content database. I guess the theoretical maximum is probably like 256 terabytes or something nowadays. 2 terabytes on NTFS, something like that. We're not going to get up to that range usually, are we? We're going to keep our databases small. So in 2010, how do we keep our databases smaller? Well, you'll hear a lot about remote blob storage, about getting the blobs outside of the system. I like that within reason. Just be careful. It's not a universal solution. Because I now have disassociated, or not disassociated, I've stored my blobs on another disk. And now I got to keep these in sync. And I got to know this performance of this disk is up to the one in my content database. And if I'm backing up and restoring that with some tool other than SharePoint, I could have issues. And the list goes on and on and on when I start to store the blobs outside of the system. So I'm not saying don't use RBS. I don't think it'll increase your performance. I haven't seen that personally. Some other people may have seen something else. The one is 20 milliseconds. And I'm going to tell you that if you have 20 milliseconds latency between the SQL and your blob storage for RBS, you've got other problems anyway. But that is the threshold. I did put it up here because RBS is kind of a buzz piece of software, a buzzword right now, and we're all going to do RBS. And we're starting to see some real-world problems with it. We use RBS a lot to solve point solutions, things like where we might do document capture. We're doing thousands and thousands of document captures. We may do those outside. But to say I'll just do it, blanket my farm with it, I'm not sure. Wrong session for that. We do have things like file size, 2 gigabytes. Somebody said that earlier. They were exactly right. Co-authoring, by the way, things like this. 10 concurrent editors per document. On a really busy document, down to 2 or 3, you could already start getting messages. Somebody else is already editing this document. But around 10 is the recommended threshold. Search boundaries. Okay. When you look at TechNet and you read through it, you've got to say, does this make sense? So 20 search service applications per farm. You'll probably never have more than 1 or 2 at the most. It's Ben at s7sys.com. Honestly, for free, I'll email you and I'll take a look at it. If you say, I need 10 service apps, just email me and we can have that conversation. Most likely it's 1 or 2. Most of these maximums won't affect you. The crawl databases, it is 10 crawl databases per search server, 10 million rows per crawl database, so technically you can have 100 million items. So that's the theoretical maximum. But somewhere between, it's really hard to say because of the size of the documents, 10, 15 million items you should start to look at fast as a search solution. Somewhere in there. And the more I use fast, the more I like it, by the way. Okay. If you are, well, that's an awesome yellow color. If you're coming up from 2007, you probably already have a lot of your usage content. How long do I have? 15. Oh, snap. You probably already have a lot of your usage content in 2007. The odds are when you first roll out your 2010 farm, they're not going to take advantage of all the new stuff, access services, and we're not going to immediately hit Visio services, for example. Be careful. Some things you may not have gotten off your 2007. I'll tell you one just bit me. Performance Point. They already had a very busy Performance Point server. We architected 2010 with Performance Point. We migrated it in. We did the testing before the Performance Point migration. It was a really busy dashboard. You see what's going on. That is actually one of those things. Same with like Project Server, bringing in busy Project Server instances into your 2010 farm. Okay. So nothing beats documenting what you already have. I know we like to document systems as well as we like to gather requirements. I'm right there with you. And as a consultant, I feel like 90% of my time writing in Word. I'm like, I can't actually get work done because I'm in PowerPoint and Word all the time. But the bulk of is documenting what you have. And the tests take a very small percentage if you do the proper planning. Because it's all about the planning and documentation. We can sort the tools. So, Web Application 101 scaling. Don't make this one hard. Web application has 2 primary physical, I call them touch points to the system. On the web front-end server, that's your application pool. So how fast is your web servers? What's the network latency to SQL? What is your load balancer technology? How fast is that? How much memory does it have? Memory is a huge factor in web front-end performance. Guarantee it. Most poorly performing web servers I have to deal with, lack of memory. They're starved for memory. Especially if you turn on publishing infrastructure. You need memory, and you need lots of it. It loves memory. Especially if you go turn on caching. The more caching you turn on, in-memory caching, the greater your application pools and the higher the number of users. So web front ends. On the back end, it's SQL Server. A site collection is stored in a content database. So can this content database serve up the data? Have you taken your transaction logs and have you taken your data and you split those onto 2 different sets of spindles? It's one of the things you can do to get performance. I know, did you talk yet, Brian? So tomorrow morning, Brian Alderman will be talking about SQL performance, and he's going to get into, I'm sure, that exact topic about getting the logs and the data separate and tuning those for the type of traffic you're going to have on SharePoint. I love the Internet Developer Toolbar. It came with IE8, it's now in IE9. I still use Fiddler a lot. I use Fiddler all the time. This is my toolkit, by the way. If you want to know what I walk into a client with, this is what I walk in with. And you may be expecting some really great, cool widget, but this is what I use. And there's one called ping. Don't forget ping, a really simple command. Ping, put a payload in it, see what the round trip is. We still set up PowerShell scripts on clients that don't have robust monitoring, just to see what the latency is every 60 seconds over a day, and just to see what that really is, and not what the network team's telling me. Visual round trip analyzers are free download from Microsoft. It does require Netmon 2.0. I used to be a big Wireshark fan. I still like Wireshark. Netmon, if you haven't played with the new one, it is really cool. It's 2.2 now or something like that, release. But it's nothing like the old network monitor tool. So really powerful. Fiddler, you know, V2 or higher, it's been out a year and a half, will actually do SSL. So it can actually decrypt the SSL in the browser, do its investigation, re-encrypt it, and send it on. So it can actually be a proxy in the middle. Everything but smart card should work. I haven't sorted that one. If you've smarted smart card with Fiddler, I'd love to know how you do that. Dev dashboard, look, this is it, the PowerShell script. You'll see this week. It'll be in your deck you get on the CD as well. All you have to do is copy and paste this into PowerShell on your SharePoint server, and this will turn it on. This one you'll see I've actually turned on tracing as well, just a heads up before you do that. The bulk, and this is what Steve Smith on Wednesday after lunch will be going into a deep dive on Visual Studio Team Suite. So he's going to take everything we just did here, and he's going to actually do it for an hour. He's going to walk you through step by step. And it's my favorite part of this presentation, and he's doing it. But that's okay. He owns the show. I guess he can. And he's going to show Fiddler as well. Very good. So we get everything up. We did our planning. We installed our server farm. We've applied some best practices. We've tested. We're ready to go. We need to start logging. When something doesn't work, the first place you should look is the logs. Or just blame the firewall team. But otherwise, look at the logs, right? Seems like we always blame the firewall. Oh, it's a firewall problem. If it's not a firewall, who do you blame? Network people. And if it's not network, you blame DNS. So we already know the top three. It's not us. That's actually often true in SharePoint, by the way. It is usually not SharePoint being the problem. It's usually all of these dependencies. Check the event logs. I take a lot of support calls with clients. I say, well, what did the logs say? And they had not looked. I'm not trying to make them feel bad, right? I mean, I want them to be happy and joy and write me a check. But they didn't check the logs. So event logs are the best place to check. If you see a big red stop sign, that equals bad, right? And what did the red stop sign say? And they walk me through it. And there's usually a lot of rich info in there. The next place we look is trace logging. I usually don't have trace logging, the verbosity turned up very high. Usually pretty low, just an exception, unless something's not working. Then I'll go tweak up trace logs, dump out a huge trace log file. ULS Viewer is your friend. ULS Viewer can actually take your trace logs real time and show you scroll on the screen, if you haven't seen it. Ultra cool. I use this to troubleshoot user profile application because it seems like every time I do it, it breaks. It's Kerberos, or it's permissions, or it's SQL. You can find that real-time, ULS Viewer. We have the web analytics built in. We have the dev dashboard. In my opinion, though, for mission-critical systems, nothing still beats a proper systems monitoring tool, whether it's NetIQ, or it's Tivoli, or it's SCOM, or it's whatever flavor you like. I know they're hard to work with. They're cumbersome. I've been there. But that's where your rich data is at. Especially if you need trend data on the performance of your system over time. What are we looking for? We're looking for the slide that didn't get put in over the Atlantic Ocean, is actually what we're looking for. And I will make sure it goes in here. And those are the slides I'm looking for. Here, hold up. I've got 4 minutes. I've got another deck. Oh, I know what they are. I'll just tell you. SQL Server, one of the things we're looking for is disk queue length. So know your I/O. They say no more than, I believe it's 2 per physical disk in the disk queue length. Look at your memory on the web front ends. Are you starved for memory? And like I said, Steve's going to actually demo this in Visual Studio. But do you have enough available CPU on the web front ends? We used to say, because it was true in 2007, 2008, maybe a little bit into 2009, SQL was always the bottleneck on SharePoint farms. But with modern SKUs on servers, you almost can't buy anything that doesn't run SQL. I mean, it's getting hard now to not get 8 cores and 16 gig of RAM. And what we're actually seeing from my world is the web front ends are the bottleneck again. I'm seeing everything move back to the web front ends because we're doing forms-based, because we're doing caching, because we have big web pages, because people are actually using the functionality of SharePoint. So I've actually now pivoted back to the web front end. So when I'm seeing a huge performance issue, the first thing I do is I just open Task Manager on the web front end. It's really simple. Just look at Task Manager and what's my performance. Usually CPU's at 100, or it's out of memory, or both. I do know one thing on a closing note here that I'll tell you about SharePoint. SharePoint is not one of those things that kind of runs and gets slowly worse and tapers off like this. What I find is that SharePoint runs like this, and when it bottlenecks, it downward spirals. Like it runs here and just crashes hard. And maybe one of the developers here could tell you exactly why that is, but I don't know off the top of my head. But I know when it decides to go, it's a snowball effect. Thank you so much for coming to the session. I am ending. My name was Ben, and I'll be around next 3 days. Thank you very much.